This is problem 17 from chapter 13. Determine the acceleration of the blocks when the system is released. The coefficient of kinetic friction is mu sub k, and the mass of each block is m. Neglect the mass of the pulleys and cord. So we're going to start off by doing a free body diagram for block A and for block B. We have the force of gravity acting downward on block A, which is equal to the mass of block A, which is just m, times g, and then I have the force that the rope exerts on the block acting upward, and let's just call that T for the tension. Then for block B, I have the tension in the rope acting to the right, and then I have the force of gravity acting downward, I have the normal force acting upward, and I have the force of kinetic friction acting to the right. Okay, so let's start off looking at block B. In the vertical direction, the acceleration is equal to 0. Therefore, the normal force is equal to m times g, and the force of kinetic friction is equal to the coefficient of kinetic friction times the normal force, which would be m times g. Let's look at the sum of the forces in the x direction, and I have the force of kinetic friction acting in the positive x direction, so that would be mu k m g, and then tension's acting in the negative x direction, and that's equal to the mass times the acceleration in the x direction. Okay, and then I can look at block A. The problem here is that the tension is not known, and so right now I have one equation, one unknown. So looking at block A, I have the sum of the forces, and let's say upward is positive, so I have T minus mg is equal to the mass of block A, which is just m, times the acceleration. Now, if block B is accelerating in the x direction with an acceleration of x, well, actually it's going to accelerate this way, so the x component should be negative. But anyways, so let's say it's accelerating this way with an acceleration a, then a is going to accelerate downward with the same acceleration. So let's just call that, can I call that a, or is that going to mess up the signs? That should be fine to say a, because it's actually accelerating the other way. I mean, if it's positive, it would be accelerating this way. And I said for block A, the acceleration was positive, which would be upward for block A. So this is the positive direction for block A. And if this acceleration is positive, then this would be positive also. So that's all good. So now I can solve one of these two equations for t and plug that into the other equation. So let's say here we have t is equal to ma plus mg, and then we can take that and put it into our equation here. So I have mu k mg minus ma plus mg is equal to ma. And then I can bring this over to the other side. So I have mu k mg minus mg is equal to 2 times ma. What am I looking for? I'm trying to find a. Okay, so I have a is equal to mu k mg minus mg divided by 2m, and the mass cancels out, and I can pull out the g, and I have mu k minus 1 divided by 2. And the coefficient of kinetic friction should be less than 1, so this would be negative, which I figured out that should be the case earlier. So, or I guess we could say the magnitude of the acceleration is g divided by 2 times 1 minus mu k. And then it would be accelerating to the left for block B and accelerating down for block A.